Hi children, welcome to maths classes. Today, let's solve problem number 3 in exercise 1.2 of chapter number systems in class 9. What is the third problem children? Show how root 5 can be represented on the number line. Okay children, we solved a similar problem in our examples. Did you remember children? We drew root 2 and root 3 and we represented them on the number line. How did we do children? Which theorem did we use? Yes, we used Pythagoras theorem. We used Pythagoras theorem children. What is Pythagoras theorem children? Square of hypotenuse is equal to sum of squares of opposite side and adjacent side. In which triangle children? This applies in right angle triangle. So, according to Pythagoras theorem, in a right angle triangle, square of hypotenuse is equal to sum of squares of opposite side and adjacent side. So, here BC in triangle, right angle triangle ABC, BC is the hypotenuse. BC is the hypotenuse and the side opposite to hypotenuse is opposite side. This is opposite side. AC is opposite side and AB is adjacent side. So, according to Pythagoras theorem, you get hypotenuse square BC square is equal to opposite side square, that is AC square plus AB square. Using this Pythagoras theorem, we solve these problems children. So, to represent root 5 on the number line, we start representing root 2 first. That is, first we do root 2, then we use root 3, then root 4, then root 5 can be represented on the number line. How to represent root 5 children? First, draw the number line and each unit should be 1 centimeter length. Draw a number line of 1 centimeter each. So, point 0 mark it as A and point 1 mark it as B. Now, let's first draw root 2. How to draw root 2? AB is of length 1 unit. Now, from B, point B, draw a perpendicular of length 1 unit. Take a protractor. From B, you can directly draw perpendicular or take a protractor and mark 90 degrees. Then draw a perpendicular of length 1 unit. Mark the point as C. Now BC is the perpendicular line of length 1 unit. Join points A and C. Join points A and C. Now how to find length of AC children? If you observe, this is a triangle. This is a right angle triangle. ABC is a right angle triangle. ABC is a right angle triangle. Right angled at B. And length of AB is 1 centimeter. Length of BC is 1 centimeter. So, we can find AC using Pythagoras theorem. Hypotenuse square, that is AC square is equal to opposite side square BC square plus AB square. What is the length of BC children? 1. 1 square plus AB length is also 1. 1 square. You got 1 plus 1. That is 2. AC square is 2. That means AC is root 2. So, the length of hypotenuse you got is root 2. AC is root 2. You got AC as root 2 here. AC is root 2. Now, draw another perpendicular at point C. What should be the length of perpendicular children? It should be of length 1 unit. From point C, draw a perpendicular. Take a protractor and mark 90 degrees at point C. Keep your protractor and mark 90 degrees children. At C, draw a perpendicular of length. What children? 1 unit. Mark the point as D. Now CD is of length 1 unit. Now join points A and D. CD is the perpendicular. So this is a right angle triangle again. We got right angle triangle ACD. What did we get, children? We got a right angle triangle ACD. Right angle is at C. Now what is the length of AC, children? We got AC length as √2 and CD length 1. Now according to Pythagoras theorem, AD square is equal to opposite side. Opposite side is CD. CD square, that means 1 square plus adjacent side square. Adjacent side is AC. AC square is √2 square. 1 square is 1, √2 square is 2. You got 1 plus 2 is 3. AD square is 3, that means AD is equal to √3. Now you got length of AD as √3. Now you got AD as √3 here again. Now what should we get? We should get √5. So proceed in the same way. Now from point D, mark a perpendicular. Draw a perpendicular from point D. What should be the length of perpendicular, children? It should be of length 1 unit. Draw a perpendicular at D. It should be of length 1 unit. Mark the point as E. Now join points A and E. D is of length 1 unit. Now you got right angle triangle ADE. That is right angle at D. Children, you got a right angle triangle ADE. Right angle at D. What is the length of AD, children? AD length is √3. AD length is √3. DE length is 1 unit. Now according to Pythagoras theorem, you can find AE. AE square is equal to opposite side square. Opposite side is DE. It is of length 1 unit. 1 square plus adjacent side square. Adjacent side is AD of length √3. √3 square. 1 square is 1, √3 square is 3, 1 plus 3 is 4, AE square is 4, that means AE is equal to √4, that is √4 means 2, so you got AE is of length 2. 2 is nothing but √4. Now you got √4 also, children. Now you should find √5. What should you do again? Yes, draw a perpendicular at E again of length, what, children? 1 unit. Draw a perpendicular at E. It should be of length 1 unit. Mark the point as F. Draw a perpendicular. Now FE is of length, that is EF is of length 1 unit. Join points A and F. EF is perpendicular. Now we got right angle triangle AEF. We got right angle triangle AEF. What is the length of AE, children? AE is of length 2 units and EF is of length 1 unit. Can you find AF now? Yes. AF square is equal to opposite side square 1 square. EF is the opposite side. Then AE is the adjacent side square 2 square. 1 plus 2 square is 4. So AF square is 5 units. AF is √5. So children, we got now AF as √5. What did they ask? They asked to locate √5 on the number line, children. So now take a compass, children. Measure, keep one side of the compass at A and measure AF. Take √5 length, children. √5 is AF. Measure AF and mark this on the number line. You got it just after 2, children. So we measured AF and marked it on the number line. So on the number line here you got root 5. Root 5 is here on the number line. This is the root 5 on the number line. So in this way we locate an irrational number, that is root 5 on the number line. So what did we do, children? We used Pythagoras theorem to solve this. First we drew a right angle triangle. How did we do? We take 1 centimeter, AB as 1 centimeter, then drew a perpendicular of length 1 centimeter. We got AC of length root 2. Similarly, from C, we drew another perpendicular of length 1 unit. Then again, we got AD of length root 3. Similarly, root 4 we drew. Then we got finally root 5. So, this is the way you should do, children. Children, this is the method 1 of solving this problem. Children, did you find this method as lengthy method or short method, children? For root 5 finding, we first found root 2, then root 3, then root 4, then root 5. This is somewhat lengthy procedure, children. Let's see another method how to solve this. Method 2. Draw a number line again, children. Each of length 1 unit is 1 centimeter. Draw in such a way. Draw a number line 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So children, in this method also you should use Pythagoras theorem itself, children. Remember, we are locating root 5 on the number line, okay? Now, we will use Pythagoras theorem itself. Pythagoras theorem. Children, in the previous method, if you observe, every time root 2 is hypotenuse here. Again root 3 is also hypotenuse. Root 4, that is 2, is also hypotenuse. Again here root 5 AF is also root 5 and it is also hypotenuse. We are getting this length which we are locating on the hypotenuse side. Okay, at hypotenuse side you are getting root 2, root 3, root 4, root 5. Okay, remember this, children. So according to Pythagoras theorem, ABC, right angle AC. AC here you should get root 5. This is our target. If we get AC root 5. See, if you get AC, that is AF here as root 5, then we can take the compass and measure and draw on the number line. So here also our target is to get AC root 5. What is Pythagoras theorem, children? Hypotenuse square is equal to opposite side square plus adjacent side square. Is it right? Yes. So, we should get hypotenuse what? Root 5. Root 5 hypotenuse we should get. Root 5 square is equal to opposite side square plus adjacent side square. Root 5 square is 5. You will get opposite side square plus adjacent side square. 5 is equal to opposite side square plus adjacent side square. So, you should split this 5 into sum of squares of two numbers, children. Let's see. How can you write 5, children? 5 can be written as sum of 1, 4. 1 plus 4 is 5. 1, 2 plus 3 is 5. This 1 plus 4 can also be written as 4 plus 1 and 2 plus 3 can also be written as 3 plus 2. Let's see here. Let's take first thing. 1 plus 4 or 4 plus 1. Okay, children. Opposite side square 1. So, one side take it as opposite side square as 1. 5 means 1 plus 4. So, adjacent side square. This adjacent side square is 4. This is opposite side square. Can you write like this, children? Opposite side square is 1. Adjacent side square is 4. That is 1 plus 4 is equal to 5. So, opposite side square is 1. That means opposite side is what, children? root of 1. It is nothing but 1. Similarly, adjacent side square is 4. What is adjacent side then? Adjacent side is root 4. That means 2. So children, if you take opposite side as 1 unit, that is in the right angle triangle, we need root 5 in the hypotenuse, A, B, C. Now we can take, see we solve this. We took 1, 4. 5 is equal to 1 plus 4. Opposite side square is 1. Adjacent side square is 4. Opposite side square is 1. That means opposite side is 1. Adjacent side square is 4. That means adjacent side is root 4. That is 2. So we got what? Opposite side as 1 unit and adjacent side as 2 units. So using these measurements, we can directly draw root 5 and then locate it on the number line, children. Instead of first locating root 2, then root 3, then root 4, we can directly measure root 5 and draw on the number line. See, here adjacent side is 2 units. So, from 0, where you will get 2 units, you will get 2 units here. So, 0 mark it as A and 2 units mark it as B. So, AB is of length 2 centimeters. Adjacent side we took as 2 centimeters now. What is the opposite side? Opposite side is BC. It should be of length 1 centimeter. To get root 5 as a hypotenuse, AB should be 2 centimeters and BC, opposite side, should be 1 centimeter. So, from B, draw a perpendicular of length 1 centimeter. Draw a perpendicular. Mark 90 degrees using protractor and then draw a perpendicular of length 1 unit. We drew a perpendicular, mark it as C. BC is of length 1 unit. Now join. AB is of length what, children? 2 units. AB is of length 2 units. BC is of length 1 unit. Now join points A and C. Join points A and C. We already know, children, here when AB is 2 units, this is right angle triangle, ABC is a right angle triangle, AB is 2 units, BC is 1 unit. Then we get AC as root 5. AC as root 5. So we got root 5 as the hypotenuse here. Now take a compass and measure AC. Measure AC. And AC is of length root 5 we got. Now mark it on the number line. See here, children, we got root 5 here. So children, using this method you got root 5. So in one step itself, if you think a little bit, that is you use a Pythagoras theorem, in hypotenuse you should get root 5. So do back steps and get what is the length of, normally we will have opposite side and adjacent side, then you will find hypotenuse. Now you do reverse. You have hypotenuse, then find opposite side and adjacent side. What is BC opposite side? What is adjacent side AB? You find it. 5 is 1 plus 4, 2 plus 3. 2 plus 3 is little bit difficult. 2 plus 3 means root 2 whole square, root 3 whole square. It is difficult to represent on the number line again. So we take 1 plus 4. 1 as opposite side, adjacent side square is 4. We got opposite side as 1, adjacent side as 2. Now AB as adjacent side 2 and BC as opposite side 1. You can locate root 5 on the number line easily, children. This is the method 2. This is the smallest method when compared to method 1, children. So if you get any problem, you first do, children. You first think using Pythagoras theorem. Can we split it into 2 numbers? Like that you think and do it. Now let's solve problem 4, children. What is the problem 4? Classroom activity. Constructing the square root spiral. What is square root spiral, children? They gave an image already. They first constructed root 2, then constructed root 3. They constructed root 2, they constructed root 3. Now you need to construct root 4, root 5, root 6 and so on, children. Then you get a square root spiral. In the third problem, we already constructed root 2, root 3. 2 is nothing but root 4, root 5. Let's construct another thing. Root 6. How do you construct, children, root 6? From root 5, we got root 5. F is root 5. From F, draw a, yes, perpendicular of length, what children? 1 unit. From F, draw a perpendicular of length 1 unit. Mark this point as G. Now, FG is 1 unit. Join points A and G. Now, AFG is a right angle triangle. Okay, this is right angle triangle at F, children. So, you can't take this. This is a right angle triangle at A. So, you should draw it correctly, children. AFG. Now this is correct, this is wrong. You should carefully do it. If you do it in this way, you will get wrong. AFG, it is right angled at F. What is AF, children? AF is of length. What? AF, see here. AF is of length root 5. And GF is of length 1 unit. What is Pythagoras theorem? AG square is equal to opposite side. Opposite side is FG. It is of length 1 unit. Plus adjacent side is AF. It is of length root 5. Root 5 square. So 1 square is 1. Root 5 square is 5. You got 5 plus 1 as 6. AG square is 6. AG is root 6. So you got AG as root 6. In this way, you can construct square root spiral, children. Again, if you want root 7, from Z, draw a perpendicular of length 1 unit. Then again, join points A and after G, H, AH. You get root 7 again. Similarly, you can do this. This is a classroom activity, children. Thank you, children. With this problem, exercise 1.2 will be completed. Thank you for watching the video. Like, comment, share and subscribe.